My friends, welcome back to my 200 3D models in FreeCAD series. Today I want to work on exercise 25. Exercise 25, I guess I will mostly focus on the primitives, but at the same time I will make it full parametric. So I will have to start with the spreadsheet to begin with, and then I'll be focusing on how we can use the primitives in our advantage in this model. So I will be working in part workbench specifically. I want to keep it on XY plane for now and place the center almost where it is now, at the center of this. Oh, that's making it difficult. Okay, there. So at the center of this big circle, and let's take a closer look at the object. It is symmetric with this axis YZ plane and also symmetric on XZ plane. So we can only create 1/4 of it like we did in one of the previous videos. But because I'll be using primitives to create these three cylinders in the middle, these three cylinders, I will have to create only this part, this connector in the mirroring part. So let's go ahead and then place those primitives while we are at it. So primitives, we have multiple primitives in the part workbench, and to create primitives we won't have to create in a sketch, and there are more primitives in there than what it is shown. It's only showing 5 or 6 of them here, but it's got more primitives options in the list here. Luckily we will be using the tube because all three of these are tube of different shapes and sizes. So let's go ahead and take one and update that. So double click on it and say this tube is 120 millimeter diameter, so 120 over 2. That's the outer radius. The inner radius is 100 over 2, so that's 50. So that's our first tube, and the height will be 50 here, and then 20 of this pad, so that's 70. So that's our center tube, and I'm going to say this is our tube center. Okay, we have two more tubes to create, so I'll take one and then copy that over. So let's take another tube. The outside diameter is 40, outside radius, and the inside radius is 25, and the height is 40 in total. All right, so this is the second tube, and I want to rename that as tube on the left. Okay, but now as you can see, it's sitting in the middle. What I want to do is I want to click on this tube, and in the data tab come to placement under the base group, and in the position, if you click on this arrow, this drop down, position opens up, and in the position click on the drop down arrow. Here we want to update one of these parameters, so it's already on the plane on xz plane, right? So we want to keep it on that plane, but I want to update so if I select it like this, I want to push it on the left, right? So I want to make it on the x direction on the negative side. So say on the x, so if I take it on the negative side, I know actually how much I want to move it over there. It's 150, so say minus 150. So that takes it over there. So that's our one tube. Let's copy that. So Control C on the keyboard while it is selected, and Control B at the same time. So that's our tube left copied over, and I'm going to say this is right. Alright, so on this one the x value is minus 150, but I want to place it on the right, so actually it will be plus 150. So take that minus off of it, and there it is. So we got 3 of our tubes placed in there. Alright, and now I have to create the connector. So there is this tool, it has join objects tool, it has 3 options in there, which is a little bit different than what we have in the Boolean operations like cut, union and intersection. So there are these three operations in Boolean, and there is this connect operations in there too. So, and this I mentioned this about because I could use this join object feature and make up this model, but I will leave that for a future video where I describe more detail how these connect tools are different than the Boolean operation. Today I didn't intend to do the Boolean operation, so I'll be precise in making this sketch. So let's go ahead and then build that sketch. What I want to do is on the XY plane, right, I want to build a sketch, and I want to build only this part of the model. So let's go ahead and take our references on this one and this one. So these are two our references that I will be using. And now let's go ahead and then open up the section view. So I want to take in an arc and take it from here to there. So this one, because it's coming on the both sides, this will be on the arc on this axis. And let's switch the mode of this arc and say endpoints and rim points, and take it from here to, don't take it all the way up on the axis, maybe somewhere here, and then make another arc. Then I want to switch back to the center and endpoints arc and take it up here. So this is the one that I'm drawing, but I want to start it a little far. So I'll do the same thing on this one, but I want to place it with this one. Right, now let's take 2 bounding lines to close the sketch. Alright, now I know that this arc will be equal to this circle radius wise, so let's go ahead and hit radius. Okay, and this one is already kind of like it's on there. So with this one, so we got that one hooked up. These two arcs will be tangential to each other. Now we have 3 degrees of freedom. Let's take care of them one by one. This radius will be 150 over 2. So 150 over 2, right? And this radius will be 100. So it's given there 100. And what else? We have 1 degrees of freedom, which happens to be this one. We know for a fact that this will be tangential to this arc. Right, so we got that quarter connector built up. So let's go ahead and rename that as sketch, say quarter connector. And I want to make an extrusion from that sketch for 20 millimeter upward. Okay, so we got that one sorted out. Now what I want to do is I want to take this extrusion and make a mirror against this face, which happens to be XZ plane. So XZ plane, right? So that's our 2 options. I want to make them union, and now take this fusion, the half portion, and make a mirror against this face, and which happens to be YZ plane. So we take that one, hit the mirror, and then go to YZ plane, right, and hit OK. So these two becomes one object becoming connector. So I'm going to say connector, right? So actually that's our object, that's our entire object, and I want to go ahead and then select all 4 of those components and make a fusion, and finally I can refine it just like that. So this is our object, exercise 25, job well done, target achieved. In the beginning of the video I said I will be making this model full parametric. So let's go ahead and then start working on this parametric capability. So now that we have the model selected, we can see which parameters that we want to put in there. First of all, I want to say I want to place the inner radius, or should I say the radius, the parameters for these outer circles. So say radius outer cylinder. Okay, that's a long name, but we'll keep it short on the alias part. So that radius, we are going for the outer radius. So this is 80. So let's make that as equal to 80 over 2. So that's our formula, and I'm going to say radius out cylinder. Okay, and then let's make this radius and say wall thick. Out means outer, so outer cylinder. Okay, I don't know why I kept this one empty. I'm just gonna say, so the thickness of this wall is 80 minus 50, that's 30 divided by 2, so 15. We can actually make that calculation here. So equal to 80 minus 50 over 2, so that's 15, and alias says wall out, right? And let's do the same thing for this, and radius outer cylinder, I'm going to say center, CENTE, or center cylinder, and that radius is 60, right? And so this was radius out cylinder, I'm going to say radius center cylinder. It's supposed to be L. Okay, and this one wall out, I'm going to say wall center, so alias would be wall center, right? And that center wall thickness is 10. So we got our parameters in there, and I want to have couple more things in there. I want to have this distance 150 embedded in there. So one more cell in there and say center distance, which is 150, and let's go ahead and then put an alias in there, say center distance, and that makes the entire thing kinda parametric, right? We will see if this 120 and this 100 radius makes a difference, but for now we are not worried about this. Okay, so we want to go back and embed these values in our model. So first of all, the center tube, we have the center radius 60. So let's go ahead and then on the height wise, we are keeping that say same, and so outer radius is, I'm going to say spreadsheet dot radius center cylinder. So that's our outer cylinder, right? That's 60. We got that one from the spreadsheet. And inner radius, I wish we went with inner radius in there directly, because but we can salvage our operation still. Radius, say spreadsheet dot radius center cylinder minus spreadsheet dot wall thickness center. So there, that's got our inner radius and outer radius fixed, and we are keeping the height as it is now. So we'll do the same thing for left, tube left, and let's say, so the outer radius is okay, outer radius is 40. Let's say spreadsheet dot, I'm gonna copy that part, and radius outer cylinder. So we got that. Let's fix this one, it will be the same. Dot radius outer cylinder minus wall spreadsheet dot wall out. Alright, so we got the left one sorted out. How about the right one? So it will be the same. So I'm gonna go ahead and then copy this formula and place it in there, so makes things easy. Now I'm thinking I should have cloned these two objects, so that way it would make simpler, but we already committed to this. Okay, so we got these two parameters sorted out, and now in the connector part we go back to the original. So that's the fusion, and I'm guessing this is the original sketch, right? We go back there, and the distance is, we took the distance from the tube left and tube right, so we'll have to do that in here, this 150 millimeter. So what I want to do is I want to make it spreadsheet, remember it's negative, so dot center distance, right, and make a negative value out of it. Okay, so we got that. I want to copy that and go to right. I want to make this one, take the minus out there. So we keyed in all the values in there. I wish I did that to start with. Now let's see if things changes now. So I'm gonna say I want to make this radius 50. That worked. So did the thickness. So wall thickness is embedded in there. I can make that thicker or leaner, and let's make this radius a little bit smaller, so 50. Yeah, that worked. I want to push them a little away, so 175. Cool, that worked. So that 100 is kind of still working as a tangential, so that's good. How about 20? Say 200. Yeah, still working fine. So we can make any model parametric and make it like anything that we want to in FreeCAD, and that's the beauty of it. Pretty great software. If I actually say, if we put our minds in it, we can do anything any commercial software can do. But patience, I cannot emphasize enough. Patience and trial and error are two pretty much important things to do modeling in FreeCAD. I hope you enjoyed this process. I will see you in the next video.